Hello, everyone. Well, first of all, I want to thank everyone who tried the interesting math problem in my previous video, and I also want to thank those who actually went through the video and watched the full speech. If you did watch the speech that I gave, then I appreciate you, and I hope that we're on the same wavelength. I hope that we have the same vision for education in America and really around the world, because I've always been a firm believer that when you have the right principles and when you have they are universal principles. I often hear things like American values or British values or French values. There's either right or wrong values. And what is right for an American, morally speaking, and it is also right for a Frenchman, and it's also right for a Chinese person, etc. Right? Principles, morality is something that uh, is an objective. There are objective systems of morality that we must all agree upon, and of course, there will be disagreements when it comes to that, because such is the nature of humans. We often tend to want to. We have a tendency to want to disagree with each other. We don't agree with each other many times. Christians don't agree with the Muslims, and the Muslims don't agree with the Jews, and et cetera, et cetera. But I am an optimistic person, and I do believe that there are broad, maybe not the theological principles, but there are broad fundamental principles that we can all agree upon, and not only that we can agree on them, but that we should, for the sake of the world, and for the sake of public order, and for the sake of just that things work in the way that they should, politically, socially, religiously, etc. But this video is going to be, some of you said that you were in anticipation of the follow-up video with the solution to the math problem that you saw in the previous video. And I noticed in the comments down below that some of you used logarithms. I was actually pleasantly surprised at that. And another person, two people, they used substitution of a number. They just actually plugged in a number. It's okay. I actually thought that was very crafty, when it comes to, because of course, if you're taking a test, right, you got to be quick on your feet. So those of you who actually plugged in a number and said, "Oh, I just did t equals this," and that's fine. But I'm not going to take that approach. I'm going to take a mathematical approach. I'm not going to take a logarithmic approach. I'm going to do it the way, but of course, there's no one superior system to the other. It's just a different approach. And since some of you already did the logarithmic approach, this one might be of interest to those students who might not want to take the logarithmic approach. I thought this method might be a little bit more straightforward, not necessarily easier, but perhaps straightforward. So thank you all for that. I was really, I liked your engagement in the comments. Please continue to engage in the comments. And by the way, some of you, I am aware, you have pointed out that in one of my videos there was a disagreement about an expression, and we keep having people who disagree with the way that the order of operations was interpreted. In the future, what I'm going to be very clear on when I do some of those problems is I want to make sure that we're all on the same page. So I will add more information to the problem. I noticed that, yes, there is room for interpretation in one of the problems that I typed, because what happened was I typed it originally, the left and the right. I'll link it down below if I remember. But basically, I was trying to get at that that the left side is not equal to the right side. And the way I typed it, some commentators were saying that they interpreted a certain way, and that's valid if they interpreted it that way, right? But that was not the message of my video, right? So in a way, you have to sort of interpret things in a certain way when you have the conditions. And I didn't make those conditions very clear in that video. So I'm sorry if anybody was confused as to what my objective was. My objective was to show that a real number is not the same thing. And I hope you all agree with this. A real number is not an imaginary number. The confusion stemmed from the way that I typed in the expression, because the expression that I typed in on the right had no parentheses. And of course, yes, if there is no parentheses, you have to do the exponent part first. And then if there's a negative symbol in front of it, you just do the negation symbol. What I was trying to get at was to type it in as the square root of a negative number. And you cannot do the square root of a negative number. So that was kind of that was where the confusion stemmed from, by the way I typed it, that some of you were saying, no, but if I do the order of operations, I can do it in the way that, and then 4 would be equal to 4. And yes, that is true if we agree on that initial interpretation. But anyway, I thank all the commentators, and I even thank people who disagree with me, because you are what makes this channel grow, and you keep me on my toes as well. Never be afraid to question me on things, right? That's what math is about. It is about questioning, and remember that our mission here is to ask why, right? Don't just take my word for it. Ask why. So if I ever, and by the way, if I ever type something the wrong way, don't be afraid to tell me in the comments, right? I mean, I would want you to tell me if I'm typing something in wrong, or um, if I'm missing a bracket or something where it's not supposed to go. So I am sorry about the lack of clarity on that question, but I will work on that in the future. I will make sure that I clarify what order of operations I'm expecting and what order of operations I am using. There was one person who said, you can't make up the order of operations as you go along. Thank you for letting me know something that I knew. I've been teaching for more than 20 years. But in math, there are situations where you do have to agree on the starting points. You do have to agree on the starting points, and those can vary. Those can vary as long as we all agree what the starting point was. So that's why in that video, it's not very clear what the starting point was for some people, and so some of you interpreted a certain way, and that. So of course we cannot make up the order of operations. The order of operations is a convention which mathematicians have agreed upon to follow, right? And therefore, they are not the order of operations, unless otherwise stated, are not optional, right? But you might find sometimes that some problems are interpreted in specific ways depending on the course that you are taking. So if I wasn't clear about that, I am sorry. Anyway, let's get to work and let's solve this problem. All right. So the moment you've been waiting for. Now, the good news is that at least the people who participated in the comment section, those of you who said that the answer to the problem was answer choice C, you are correct. And I'm putting here, this is the original problem. If x equals t minus 1 is the index, radical t, and y equals t raised to the t over t minus 1, and the value of t is greater than 0, and t cannot equal 1, which of the following choices represents a relationship between x and y? Right? Well, the first thing that you could maybe perhaps realize, by the way, the prerequisites for this problem, you got to know your laws of exponents. I'm not going to list them here because I have so many things going on today, but that's why I always tell you the prerequisites. And that's why I never like to place people in the wrong class. I don't like to do that because if people are placed in the wrong level, they will struggle. So if you have not had the laws of exponents, then of course none of this that I'm going to say is going to make sense. If you have studied the laws of exponents, then you're going to understand perfectly where I'm coming from. Now, you notice that the expression on the x on the left side, remember that what you do to one side, there's a fundamental principle in equations. What you do to one side, you must do to the other side. You cannot play favorites with equations. You have to treat both sides equally. Both sides. So what you can do is, if I raise the t minus 1 radical t, if I raise that to the t minus 1, I'm actually going to get t. And if I get t, then that means that I have to do it, of course, to the left side. So now I have x to the t minus 1, which is equal to t. Now, once we have that value, let's look at what the y is saying. We have the y equals t raised to the t over t minus 1. All right, but now we already know, based on this principle here, the value of t, right? So therefore, we can rearrange and do some clever substitution here. That means that y is equal to x to the t minus 1 And remember, you still have, when you're, this is something that students often forget, when you're doing substitutions, you still have to take into account the exponent, right? Because all we've done here is we've plugged in x to the t minus 1 for t, but there's still that t over t minus 1 in the original expression, right? So we actually have to put that in. So that's t over t minus 1. And if you know your principles, when you have a fractional sort of expression like this, if you cross out the denominators here, I'm going to use red, these denominators actually cross out. So now your expression looks like y equals this raised to this, x to the t. Right? But you already know that t is equal to x to the t minus 1, right? Where am I getting that from? Remember what we said earlier. We said that the value of t, look on the first line below the choices here. We said that the value of t is x to the t minus 1. I just want to make sure we're all on the same page with that. So that means if we do that, we also know that y is equal to, well, we have x here, and we're going to raise that to, since t is also x to the t minus 1. This is all algebraic manipulation. Now, it looks a little sloppy, but if you remember, if you've got your exponential rules down pat, that means that when you subtract exponents, it indicates anytime you see a subtraction of exponents like this, it could indicate, it could be rewritten as a division, because from the laws of exponents, when you are dividing by the same base, you have to subtract the exponents, right? So I'm going to put it on the right side. You can actually write this x to the t minus 1 as y equals x to the x to the t divided by x to the 1, which is just x, but I want to put the 1 in there just so that you see the principle, right? X to the t divided by x to the 1 could be rewritten as x to the t minus 1. And, but why? I always ask why. Why did I do this? Why do I have to do this? Because I already know what is x to the t, right? Look a little bit earlier. We said that x to the t is y. And therefore, y equals x to the y over x. And the only way from here, we have a denominator of x, and therefore, if I multiply both, well, if I raise both sides to x, these x's will cross out, and now I have y to the x equals x to the y. And the only choice that matches this is C. Well, in C, it's x to the y equals y to the x, but the order doesn't matter here, but it's still the same relationship, right? So let's look at it again, just in case, right? First, we rewrote it as this, y equals x to the t divided by x to the 1, but we said that we did that because I knew what x to the t was, and x to the t was y, right? So because of that, you have this relationship here. Let me know what you think. Let me know if anybody did it this way or a similar way. I know some of you took you used the process of logarithms. Some of you looked at this, but you got to brush up on those as well. Some of you just use substitution. You said that you set t in the original problem. You just basically went with the condition, and you said that you just plugged in t as greater than 0 and not equal to 1. So some of you said t equals 2, did the plugins. That's fine too, but I want to kind of to show it a little bit more mathematical than that. All right, thank you everyone, and I'm going to be posting another video probably later today, because there was another one of those a set of problems that students are really having difficulty with in this country, and we got to talk about them.